Well, good morning to one and all. My name is T. Naresh. Here the subject is power system analysis, and the topic is about the probabilistic short circuit analysis by Monte Carlo simulations. The abstract of the topic is the probability distribution of the short circuit currents in a bus or a section of a line represents basic information in planning, reliability, and risk assessment studies. This paper presents two methods for the development of the probability distribution of fault currents. The first one is based upon a Monte Carlo simulation, while the second utilizes analytical expressions derived from the probability theory. The Monte Carlo approach is more general but requires an extensive computational effort. The analytical method is only applicable to the three-phase faults but provides an accurate determination of short-circuit currents at a much reduced computational cost. For both approaches, a method has been developed to determine short-circuit currents for faults along various points by recalculating elements of the bus impedance matrix without a need to invert each time the bus admittance matrix. First, the introduction. The Monte Carlo method or the simulation is a mathematical method for the calculating probabilities of several alternative outcomes in an uncertain process via repeated random sampling. It also works well in sensitivity analysis and correlation of input variables. If the input describing system are uncertain, the prediction of the future performance of the system is necessarily uncertain. This is that is, the result of any analysis based on inputs represented by probability distribution is itself a probability distribution. In order to compute the probability distribution of predictive simulation results, the most common technique for propagating the uncertainty in the inputs to the uncertainty in the outputs is Monte Carlo simulation. In a Monte Carlo simulation, the entire system is simulated for a large number of times. By default, each simulation is equally likely and is referred to as a realization of the system. Here, the system is then simulated through the time, given that the particular set of input parameters such that the outputs of the system can be computed. Monte Carlo simulation. Monte Carlo simulation is a mathematical method for calculating the odds of the multiple possible outcomes occurring in an uncertain process through repeated random sampling. This computational algorithm makes accessing risk associated with a particular process convenient, thereby enabling better decision making. Also referred to as the multiple probability simulation or Monte Carlo method. This statistical technique uses randomness to solve probabilistic problems. Also, it can perform sensitivity analysis and correlation between input variables. It finds its application in prediction and forecasting models. Given the next slide is all about the graph, which related to the correlation distance and the three varying materials which uniformly been increased or uniformly it been decreased. Whereas, whereas the second is about the Monte Carlo simulation, which deals with the probabilities, chances of success, potential risk with the schedule and budget, and the range of outcomes are these two, which are nothing but the chances of success, potential risk with the schedule and budget. And this pie diagram is nothing but the predictive approach, repetitive simulations, probability distributions, is which is all about our topic Monte Carlo simulation. Here, the predictive approach which is present in the above slide is related to the which it determines dependent and independent variables to obtain the desired range of findings. Probability distribution. This method identifies independent variables as they are responsible for different possibilities of multiple outcomes that would occur. It is one of the best ways to find uncertainties accurately and getting prepared for the same accordingly. Repeated simulations. This technique allows Repeating the simulation n number of times, it gives the results that are more likely to affect a particular process. And the tree diagram is all about the draw, fault, location, and type. Determine all protection breaker pair able to eliminate specific short circuits. That is location and type, which as used in simulation, draw damaged equipment and eliminate pairs where it occurs. The protection of the circuit breaker. Draw operating time for all the efficient devices which able to eliminate the fault and the selector of the minimum duration of the short circuit. And at last, the applications. Applications of this Monte Carlo simulation is about the project management, finance, business, science, and engineering. At last, the conclusion is load in short circuit analysis is usually neglected because the short circuit current magnitude which that flows from conventional rotating machines is significantly greater than that of the short circuit current which the magnitude changed by the loads. However, as distributed loads unbalanced in phases have been connected to a grid, whether the currents that flows from them affects the magnitude and angle of the short circuit current. Thus, the objective of this study is to develop a short circuit algorithm which is able to analyze the effect of unbalanced loads and the phase shift through the transformers the short circuit current. For this purpose, this study adds the steady state short circuit models of the loads unbalanced in phases to sequence the network. That's what the Monte Carlo simulations and the probabilistic short circuit analysis of the particular Monte Carlo simulations is to be done, and we will understand the abstract of this presentation, and we are done our introduction, and we try to state and understand what actually the Monte Carlo simulation is to be, and related graphs are being presented by us and references from the net from the Google. Thank you.